Come here. If you have a broken leg, you should be here. Okay. pH is such a big deal that we're working on it again for the 4th day in a row. pH is just like, for a biological system, it's like measuring the temperature, for example. It just gives you a good idea whether things are working the way they're supposed to, whether it's excellent for just monitoring what's going on, making sure that the process is the process you want, or everything's normal or unnormal, right? So we spent a lot of time first. We first started finding pH, and the equation for pH was negative log of hydrogen ion, right? So you got to get this hydrogen ion for different things. Now for a strong acid, how did you get the pH? How did you get the hydrogen ion concentration? Do you remember if it was a strong acid? It was just the molarity. If it's 0.2 molar HCl, well then hydrogen ion concentration is 0.2 molar. And then we started finding pH of weak acids. How did we do that? We did ice, but we had to do ice of a certain reaction. What was the reaction, remember? It was the what reaction? The Ka or the Kb reaction? It's the Ka. And that's always Ha going to H plus and A minus is conjugate base, right? Whatever that is. And then you had to do ice. Okay? And the following day, last class period, we had a weak base. And what's the pH? How do we do that? We did ice again, but for what reaction? Not a Ka reaction, but a Kb reaction, right? You had to write a Kb reaction. So if my acid is Ha, my conjugate base would be just A, right? Well, technically A minus, right? You write an A minus. Just in general, right? Plus water for a Kb reaction, and that gives OH and the conjugate acid, HA. Okay, and then we had to do ice. Okay. So today, we are again calculating the pH of weak base solutions. So that means, again, we have to do this. However, we are going to open ourselves up to a much wider source of weak bases. Before, they had to be in that little table, right? Okay, let's take a look at this. Up to now, how do we recognize, AJ, that a solution contains a weak base? To this point right now. No. It's not strong. Well, kind of, but it's in the chart, right? Because they had to give us a Kb, otherwise we can't do it. It had to be in the chart. Exactly, it had to be in the chart. But now they're saying, okay, no, there's a lot more. They're saying that there's a second source of weak bases, and they're saying they're in the table of weak acids. There's bases there? Mari, where are they? Those are all weak acids. Well, hang on. Think of it, instead of thinking of weak acids, think of they're all conjugate acids. So couldn't you just write their conjugate base? And then you'd have it, right? Every single one of these weak acids has a conjugate base. Let's pick one. Let's pick HClO. What is its... Now that's supposed to be a weak acid, Monica, but what's its conjugate base? ClO negative. There's one. Right? That would be a conjugate base. That's a base. If we put ClO negative in water, Caroline, that solution would be acidic, basic, or neutral. if you put ClO negative in water, the pH would be why basic? Because ClO minus is a base, right? It's a conjugate base, but it's a base. It would be basic. Lauren, let's pick, I don't care, this guy. What's the conjugate base you get out of that? It was H2S, that's the conjugate acid. Conjugate base would be, how do you get conjugate bases? Rip off a H plus, rip off an H plus. What would be left? Just the HS with a what charge? You got to take away a positive. It was 0. Take away a positive, you end up with a negative, HS negative. All right. How about this thing? Ramiro? What conjugate base would be there? Perfect. All right. Okay. I'm on to, let's back up a little bit. Okay, so we have these bases in water. If this is in water, that solution is going to be basic, right? 'Cause they're conjugate bases. How do you get a Kb value, right? Because we're going to write the Kb reaction. We got to do ice, but you need a number for Kb. All you have are the Kas.
So you have to do Kb first?
There's an equation. It was in the reading. Kw equals what times what? Ka times Kb. So that means all my Kb values are Kw over Ka. Now what was Kw again? 1 times 10 to the negative 14. So that's what Kw was. And if you want to get Kb for, I don't care, this guy, you do ice on them, right? You do the Kb reaction, and you have to do ice. You need a number for Kb. You have to use this equation, but what would Ka be?
This is what is in the chart.
Yeah, there it is. This would be the Ka you'd have to plug in. Make sense? Okay. Last question. This is the last. This is what I think makes these problems confusing, if they're not confusing enough. But how do you get all these bases we wrote? How do you get them into water? So here's this is a vial on a shelf, right? This chemistry lab. We have all these chemicals over there. So can I go in a shelf and find a bottle that says HS minus, or a bottle that says H2BO3 minus, or a bottle that says OCl minus? No, because if you did, it's like grabbing a battery terminal. Why am I saying that? All these compounds have a charge. They're negative. They have a charge. So, but compounds in a bottle, they don't have a charge. They're the N word. They're neutral. Otherwise, you can't. Right? They're electrified. It ain't gonna happen. Everything has to be neutral. So, what they're going to do is you need a cation. Remember this from Chem 1401. These cations, you could put them with any anion you wanted, and it would dissolve 100%. What were those cations? They were all group what? Ramiro remembers, they're all group 1. Lithium, sodium, potassium. You put those ions with anything, it'll always dissolve. That's the only way to do it. So they're going to say, okay, I'll pick one. Lithium, LiClO. That's how you get it into solution. You find a bottle that says LiClO. You find a bottle that says KHS. You find a bottle that says Na, doesn't that look weird? NaH2BO3. That's how you get it in solution. And I've done this so much that when my brain sees these compounds, I don't even look at the alkali metal, the lithium, the potassium, the sodium, because it never does anything. In any chemistry problem, they're always just technical word starts with an S? Does anyone remember? Spectator ion. They never do anything. So I look at LiClO. I don't see LiClO. I just see ClO minus. I just see HS minus. And I just see H2BO3 minus. Because those lithium, sodium, potassium, those alkali metals, the only purpose they serve is that you can put the stuff in a bottle. That's the only purpose. Okay? So what I'd like to do is go to the boards, and we're going to work several questions. And the very last one is going to be an actual full-blown ice problem, and we'll probably go back to the chairs and work out the math. Okay? Let's just practice first. So come on up and let's knock these out. Okay? Well, hang on. Let's do this first one together. Right? So you know what I'm after. You have NaCN. Oh, let's pick on Victoria. Victoria, let's do this one together. Would this solution be acidic, basic, or neutral? Sodium cyanide. I'm picking on Victoria. Basic. Does everybody agree? Yes, she is correct. Because of this thing, right? Okay, now, and write the reaction that controls the pH of the solution. So would you be writing, Alyssa, she said that it's a basic solution. So do you have to write a Ka reaction or a Kb reaction? You have to write a Kb type reaction. Okay, now Jasmine, you remember what Kb type reaction would you write that's going to control the equilibrium, control the pH? Let's leave the Na part off, though. It'll make life easier. Just do the Cn part. Otherwise, you got to remember to write it on the product side. It's easier to leave it out. Plus H2O, OH negative, and HCN. Exactly. That's the game we're playing for this first one. Make sense? So bring your handout with you because you're going to need the tables. So try B. Okay. Determine whether 0.18 molar LiOCl is acidic, basic, or neutral. And depending on your answer, write the corresponding Ka or Kb reaction that's going to control the pH. Be nice to each other. Be nice. Okay, 0.18 molar LiOCl. Determine whether it's going to be acidic, basic, or neutral. And depending on your answer, write the corresponding equilibrium that controls the pH. Now you see the Li part, so that should be a real hint as to what table you should be looking in. Right? You see an alkali metal there, so odds are there's an HOCl in that table of weak acids. Oh yeah, they flipped it around. I don't know why they did that. They did ClO, didn't they? Okay, but it's the same thing. Exactly. Right? So I think everyone is writing basic, right? And then they wrote the conjugate base plus water gives the conjugate acid and hydroxide. Right? No, we're stopping there. We're not doing ice or anything. We're just setting things up. So we determined that it's basic, and we wrote the Kb reaction. Try C. Do the same thing. Determine whether it's going to be acidic, basic, or neutral. And write the corresponding Ka or Kb reaction, assuming that it's going to be acidic or basic, right? Because neutral, you can't write anything. Now, looking at this compound, odds are, where can you find it? The table of the weak bases, right? Because you don't see any alkali metal there. So I would hunt for that thing in the table of weak bases. See if it's there. Is it?
Yes.
It's there. Alyssa says it's there. Okay. And just go ahead and do the rest of these. Yeah? Mm-hmm.
So if it's in the base, that table, basic.
If this is so this is in the table of weak bases, so it is a base. So when you put it in water, it's going to be basic. So you have to write a KB reaction, which is what you did. Oh no.
No, I did it. I thought it was an acid.
Oh, you didn't write either one because KB reaction is a base plus water gives OH minus plus the conjugate acid. So this is really close. This is just OH minus. The Ka reaction is just HA going to H plus plus A minus.
So that's how we tell if it's in the table.
Yeah, for this guy. But not all of them are. Like this one's not in the table. OCl. He's in the table. He's the conjugate base. All right? This one, the reason why you said basic was because HOCl, sorry, where are we at? OCl minus, this NaOCl, his conjugate acid is HOCl. So that means this must be a conjugate base. So that's why he's basic. And that's why you wrote a KB reaction.
Okay. I was about to say this way is much better than less. I guess it's the same way.
It's exactly the same. The problem is this way is more complicated because we have to determine what type of compound this is. And that determines what type of reaction we write.
I was talking about last year when I took it. I struggled.
Well, it was the same thing. You did the exact same thing. Now make sure you agree with the folks around you. Technically, you should have a little plus here. You added an H plus. But it's okay.
I'm confused. If it's in the table, it's basic.
Now what is this? What is HF? It's,
No, it's an acid.
that is in the table of weak acids. So what is it then? It's a weak acid because it's in the table of weak acids. So you have to write a Ka reaction. All right? So in D, good, okay, good. So everyone agrees with C, right? And whether you write it as C5H6N plus or HC5H5N plus, same thing for C. D, see if everybody agrees on D. Right. Hopefully they're saying it's acidic. Good. I see people writing acidic for D. Because it's right in the table of weak acids. So you have to write a Ka reaction. Okay. You're onto something. There's something funky going on with KCl. Okay. If you're on E, let's take a look at E, because E is kind of a trick question in a sense. Remember, the K doesn't do anything, so you don't even look at them, right? All you're interested in is that Cl minus. So if you're going to guess anything, he would be a conjugate what? Base, right? So just write a Kb reaction. See what happens. You don't have to write it. Just watch. All right? And that's going to form what and what? Hydroxide and HCl. Now, hopefully you memorize these 6. Remember HCl, strong acid. Do strong acids form, or do they fall apart 100%? They fall apart 100%. You can't form, you can never, ever, ever form a strong acid. That means chlorine and water, chloride, anion, and water are just going to sit there and do nothing. So the pH is going to be neutral. So really, the answer is going to be neutral always when the anion is what? The conjugate base of a strong acid. Conjugate bases of strong acids always end up being neutral. They're so weak. They're super weak. So do you recognize F then? It's that perchloric acid is HCl4. So the answer to F would also be neutral. You can't form perchloric acid. Okay, does that make sense? Let's check out these two. Okay, we're given the table. Write the hydrolysis reaction, if any, for each solution, and determine a numerical value for its equilibrium constant. In other words, here's your compound, NaF. Determine whether it's acidic, basic, or neutral. And then, depending on your answer, you'd write the corresponding Ka or Kb reaction. And then, after that, give me the Ka or Kb number, depending on which one you wrote. HF isn't a strong acid. HF is weak. Yeah. And if you're not sure, you just look in the table. There's HF sitting there. So is that solution going to be acidic, basic, or neutral?
Basic.
Basic. So you should be writing a Kb reaction. So not only write the Kb reaction, but then find what Kb is. And AJ, leave the Na part out. Otherwise, it just, you got to remember to put it in on the product side, and it gets ugly. Mara, you have NaF. That means you don't have HF. You have F. There you go. There you go. Technically, you have F minus. Yeah. Yeah. And then give me the Kb, Lauren. You got to give me what the Kb is going to be. So hopefully you're writing a Kb reaction. And then you got to give me what the Kb is going to be. Yep. 1 times 10 to the negative 14 was Kw. So do that for both of these. Did anybody get a Kb number? Yeah, 6.8 times 10 to the negative 4. Need a calculator? You can borrow this one. Oh, good question. You have to use the Ka for F minus's conjugate acid. And that's got to be HF. And that's where I just copied Ramiro's number. He put 6.8 times 10 to the negative 4. I assume he's right.
Is that one right? HF fits in?
Yeah, he's right. You're right.
I don't know.
What'd you get? It should be a really dinky number. Yeah. 1.47 times 10 to the negative 11. Did you get 1.47 times 10 to the negative 11?
Yes.
All right. Excellent. That's how it should be working. Okay. Here. Okay. So just set up B. Yeah. Oh, we don't. Well, we just want a number for Kb. So that's for the, we're not going to go full blown and find pH or anything yet. So just find the number for Kb that you're going to need to solve the question. And Kb is Kw over Ka. Yeah, Kw is Ka times Kb. Yeah. Yeah. Yeah, Kw is Ka times Kb. You're right. So this one we know is 1 times 10 to the negative 14. This one is, you got to find it in the table. Which acid you going to look up?
Wrote it again. I didn't know I had it. So it's Kf.
There it is. It's that one. You got it.
Shouldn't it just be itself? Right?
For B,
Yeah.
you're saying that it would be neutral. Oh, it would be this would be a good trick question. If I change one thing, what do I change? Change the 2 to a 3, that would make this neutral. But it's a 2, so it's actually a problem, all right? So you can't write neutral for B. Yeah, so you'd be 1 times 10 to the negative 14 divided by this,
Yeah.
and you'd have it. I got 1.47 times 10 to the negative 11.
Wait, I got that for the
Oh,
first
this is the
one.
next one. Okay, you're ahead of me. You're ahead. Okay, you're doing good. Okay, make sure your answers agree with the folks around you.
Can we still sign up for the chem club?
Yeah, you just email me and I put you on the list. You missed meatless pizza. It's a good Catholic club. We had mushroom and cheese. It was actually good. Oh, that sounds too good for you.
Is that right?
Compare it to what I think that's what Maria got. So I think you're right.
We're supposed to keep going.
Yeah, try B. Wrap up B, and then we'll do the big finale. So make sure you can get an answer for B. I think people get 2.2 to the 10 to the negative 11 for Kb for the potassium nitrite solution. Molarity. It's gonna. Yeah. We're just setting things up. Because from experience, I've found that this is the hardest part. This is where people screw up, right? You see a solution. This is what's, because the question that's coming up is going to be the full-blown problem. So the first question you ask yourself, is this solution acidic, basic, or neutral, right? And then once you answer that question to yourself, you write the corresponding Ka or Kb reaction. And then you do ice, right? Okay, let's jump way down to the most difficult question I can ask you. That's number 5. Okay? So I would suggest going back to your desk so you can actually write this out and find the hydroxide concentration and pH of a solution of 0.77 molar NaOCN. What is OCN? Okay. Find the hydroxide and pH of an aqueous solution of 0.77 molar sodium NaOCN. Whatever the heck OCN is. I should look that up. So nothing's really changed. Ask yourself whether the solution's acidic, basic, or neutral, and write the corresponding Ka or Kb reaction, depending on what you just determined. Then do ice. No? it figured out. Everyone's writing a KB reaction. You realize it's going to be basic. Hard is subjective. Nope. Yep. Yep. There you go. Good. See what everyone else got. See. You think? Oh. You should watch Chemistry with Dr. Smith. And see how it's nice? Negative 11, so you can drop this part. That's KB. How'd you get it? Yeah, KW over KA. Do you know where I got this number? Because that's the KA for which acid? Yeah, exactly. You got it.
Then that's the thing you put over here.
That's the KB. Yep. Because you're a KB reaction, so this has to be a KB number.
Oh, okay. Right. I wasn't sure.
It equals products over reactants. Yep. Yeah, so he would be X, he'd be X, and that guy's 0.77 minus X. And it's 10 to negative 11, so you can drop some stuff. Okay, let me scribble some stuff down. Jasmine, what did you get for a KB?
For KB,
Yeah.
I got 2.9 times 10 to the negative 11.
2.9 to 10 negative 11. Anybody else get 2.9 times 10 negative 11 for KB? Okay, good. That's good enough. Oh, I should fill this out, right? 0.77. All the way down, dashes so you don't screw up. Zeros. X's. Negative X. So my KB is 2.9 times 10 to the negative 11. That's got to be x squared over 0.77 minus x. And drop the x because it's 10 to the negative 11. So you do some math. And you get your x to be
4.73 times 10 to the negative 6.
that?
It's the lowest criteria for digits.
Okay, so it's around 4.7 or so times 10 to the negative 6. That's my x. They want to know concentration of hydroxide. Concentration of hydroxide is X, exactly. There it is. Here's our answers. So this guy is concentration of hydroxide. We're halfway there. Then they want to know pH. Several ways to get pH. I like just taking the negative log of this and get POH, and then subtract from 14. And what'd you get for pH?
8.67.
Around 8.7 or so, it sounds like. Okay? So it's not too bad. I think it's doable. Okay. So just to go over this one more time, what I strongly suggest is looking at the compound, asking yourself, is it acidic, basic, or neutral? And always cover yourself with neutral because there's going to be some trick questions, right? And if you answered acidic, write a what reaction? Ka reaction. And then you have to do ice, right? Look up the Ka. Okay. So let's hand back some